Good morning, grade 10s. Happy Friday. Welcome to the last lesson of the week with Online Maths Core. Today is the 17th of the 4th, 2020, and we're doing rational exponents. Rational exponents, the idea is probably going to be new to you, to the vast majority of you. It is a little bit of a complex idea, but it is a very helpful idea. Okay, so I want to talk to you about square roots, and I want to say to you, my black is running out, and of course we're on lockdown, so P&A is not open for me to replace it, so blue it is. Okay, the square root of 4. You can already tell me the answer to the square root of 4 is 2, right? But why is the answer 2? Yes, because 2 times 2 is 4. But if I was using exponents, why would the square root of 4 be equal to 2? Okay. How do we write 4 as a product of its prime factors? Well, 4 can be written as 2 squared. Do you agree? 2 squared is 4. And what do we do when we are square rooting exponents? Well, we divide the power by this number on the outside. So, if we had to take 2, the power, and divide it by 2, the number on the outside, I'm left with 2 to the power of 1, which is simply 2. Okay, and it would work the same with cube roots. Why on earth is the cube root of 64 equal to 4? Now, I've taken this out of my head. Let's see if it works. Well, let's try it. If I had to write 64 as a base of 4 even, I would have the cube root of 4 cubed. And what do I know I do as an exponent? I divide the power, or I divide the exponent by the number on the outside. So I divide this by 3, and I'm left with 4. And it is this idea that rational exponents is drawing on. So there are some rules or some laws. And the rational exponent laws say that if I have a base raised to an exponent that's a fraction, how can this actually be written? Well, earlier you told me that when I take, or not even earlier, but what you should know is that if I take the square root of x to the power of 10, this answer is x to the power of 5. Why? Because I said x to the power of 10 divided by 2. That gave me x to the power of 5, right? So where does this 2 come from? This 2 comes from the outside. So thinking of this, if I can write this x as a fraction, where does this a come from? That a comes from the outside. And what do I have on the inside? X to the power of 1. Just like here I had x to the power of 10, and that 2 came from the outside. So that is the first law, that if I've got an exponent whose if I've got a power whose exponent is a fraction, I can write it in this form. So that means if I had a power whose exponent looks like this, who does the a belong to? The a belongs to the outside, the root sign, and this is x to the power of b. And the last little rule that you have to note, that if I have a negative fraction, so x to the power of negative b over a, this negative belongs to the base, not to the root. So still root of a, but x to the power of negative b. Okay, so those are your little rules, but it really just draws on the idea that if I am rooting a power, so let's think about the cube root of x to the power of 12. How can I write this as a power with a fraction exponent? Well, it's x to the power of 12 divided by 3, which you know ends up as x to the power of 4. This division, the denominator, belongs to the sign with the root, and this numerator is the base's power. Okay, so if I look at the first example, it says example 1, show that the square root of 8 equals 2 times the square root of 2. Can I compare these two things right away? The answer is no. The only way I can compare things is if they look the same. So I want to rewrite this to look like a 2. How do I do that? I can rewrite 8 as the square root of 2 cubed. Okay? On this side, I've got 2 times the square root of 2. Okay? How can I take this out of the root sign? Well, I know I should be able to divide the power by the outside value of the root. So, keep the base, power divided by 2, divided by that, equals 2 times, I'm doing the same here. This has an imaginary power of 1, and there's a 2 on the outside, so it's 1 divided by 2. Okay, exponent rules that are happening here. 2 times 2, like bases, keep the base, add the powers. Remember that this has an imaginary power of 1. So on this side, I've got 2 to the power of 3 over 2 equals keep the base, add the powers, 1 plus a half. Remember, 1 plus a half, if I'm adding fractions, I must have like denominators, so it becomes 2 over 2 plus a half. And what do I notice? 2 to the power of 3 over 2 equals 2 to the power of 3 over 2. So therefore, these two things are the same. These two things are the same. Remember, if you're asked to show that two things are the same, you must make the left-hand side look the same as the right-hand side. And that's what I did. Okay. So the next example, example 2, asks us to simplify 16 to the power of a half plus 9 to the power of 3 over 2 minus 5. Okay, simplify, so not solving for anything. Let's rewrite this. We see the powers, and I know I can write these as square roots or roots. Let's see what happens. So this is, the root power is 2, and 16 has a power of 1, plus, here the root power is 2, and 9 has a power of 3, minus 5. Oh, crack on my window. Okay, let's see what happens. So I can easily find the square root of 16, which I know is 4, okay? And what is this? The square root of 9 cubed. 9 cubed is 729 minus 5, okay? 4 minus 5, okay, I'll do it all at the end. You could join it together now. This has a square root. The square root of 729 is 27 minus 5. Adding those all together, my answer is 26. Okay, it's a little bit of a confusing topic, specifically because you haven't seen it before. I'm going into the exercise, and I want to show you some things in the exercise. So in exercise 4a, it says solve for x to the power of the third equals 3. So I've got an equation. It's asking me to solve. I must get a value for x, okay? It's not an exponential equation because my x is not in the exponent. But I have this, and I know I can write an exponent as a fraction. I can write it as a root. So I have the root power of 3 coming from dividing by 3, and I have x over here. Okay, so remember this x is an imaginary power of 1, but it's actually irrelevant, equals 3. How do you solve for x? Okay, how do you get rid of this cube root? Well, the opposite of cube rooting is cubing. What happens? The cube root and the cube cancel. I'm left with x equals 27. And let's see if that's true. If I had to substitute this in here, and I had 27 to the power of a third, okay, what would that mean? It would mean I've got a cube root of 27 base with a power of 1, and the cube root of 27 is 3. So it works out. Okay, I want to do a few more like this with you. We've got x to the power of 1 over 5 equals to 2. Okay, so let's write this as a root. I've got the fifth root of x is equal to 2. How do you get rid of a fifth root? Well, I fifth power it. Why? Because the roots and the power cancel, and I'm left with 2 to the power of 5, I'm pretty sure is 32. Yep, 32. And that would be your answer. Okay, you've got a few of them to do in the exercise. C, D, E, and F. What would happen if I gave you F? Let's look at F. F looks like this. And perhaps you'll actually see this later on in equations. But just very quickly, if I give you x to the power of a half minus 6 times x to the power of a half minus 3 equals 0, and I ask you to solve for x. Yeah, you definitely will see this in equations. But just very quickly, it means I must make this equal to 0 and I must make this equal to 0. So if I had equal to 0, let's just look at things like that. How would you solve for x? Well, I would take the negative 6 over, it becomes plus 6, and I end up with x to the power of a half equals 6. Let's rewrite this now, rather, as a root. I've got the square root of x is equal to 6. How do I get rid of it? By squaring this. That and that cancel. X equals 36 would be my answer. Okay. Right, I don't know if you remember, but on Tuesday when we first looked at these things, I think it was Tuesday, exercise 2, when we did multiplication and division, I said that you only had to do A, B, C, D, and E. That's because now you can try look at O, K, L, M, and N from exercise 2, and the picture will be up on the Instagram page. And then, from today's exercise, you can go look at C, D, and E for me. Perhaps we should look at this rather when we do equations later on. Okay, good luck grade 10s. Have a good Friday, and we'll see you on Monday. Exponents is almost finished, and then you're moving on to equations.